My name is Alex Williams, founder of the New Stack, and you're listening to the New Stack podcast from Cloud Native Day, brought to you by Cisco. Check out Mantle, Cisco's open source microservices infrastructure, pulling together the best of open source projects, including Docker, Kubernetes, and Ansible. Learn more at mantle.io. That's MANTL.io. Hey, it's Alex Williams of the New Stack here at Cloud Native Day in Toronto, and going to chat a little bit with Jeff McCormick of Crunchy Data Solutions. Hey, Jeff.
How are you doing?
Jeff, I'm interested in what you're going to discuss today related to how, and I'm looking at your description of your talk, how you leverage open source cloud technologies like Kubernetes and Prometheus to provide a set of data services around the PostgreSQL database, and what is this idea of crunchy containers and what they are?
Yeah, what I'm going to talk about today is kind of a case study of how we leverage Docker and Kubernetes to basically automate the build out of our deployment of Postgres, and beyond that, kind of a toolkit that Postgres DBAs and administrators would use to not only deploy Postgres, but to do administration and monitoring. I'll mention also all of the technologies today that I used. Being open source was really a goal from day one, and I'll also describe kind of what the open source project resulted from this, what it looks like, and how people can maybe use it as a case study for building their own database as a service, not necessarily just for Postgres, but people can use it maybe as a case study.
Okay, take us from the start then.
Okay, so probably about 2.5 years ago, customers were asking us how to run Postgres on PaaS platforms. Specifically, back then it was OpenShift. And Red Hat started a transition to Docker as the basis or the foundation of their new version of OpenShift. And that was really the impetus to get me to develop these containers. People wanted to run open source Postgres as well on that PaaS platform.
What was it that about it that intrigued you?
Well, customers really wanted the ability to rapidly spin up and provision something complicated like a database, and then also tear it down as well. And they wanted the same kind of efficiencies that they saw with PaaS delivering for web applications, but also in the database stack. So that was really the interesting problem, was taking something that dealt with persistent data like a database and making it so that it would behave and coexist with other cloud-enabled applications. So it was a pretty interesting challenge, especially 2.5 years ago when we first started this, and that began the kind of the evolution of developing, not only just a Postgres container, which was the initial thing we wanted, the objective, but right after that we started seeing people asking for other cloud-enabled features of Postgres, things they were familiar with, and including other Postgres open source utilities and frameworks. So that is kind of what it's evolved into now, is a open source toolkit of containers all centered around Postgres.
What made it? Was it the packaging capabilities that they found?
Yeah.
Useful.
Yeah, it was the packaging and encapsulating all of the complexity of a database, and even the administration and tooling around it. So it's the packaging and then rapid deployment, and being able to spin up and abstract complexity, like building a Postgres streaming replication cluster. That's something now that this Docker container technology allows me to do in just a few seconds, is to spin up a relatively complicated Postgres cluster configuration. So it's that rapid automation that really people, I think, see the real big potential for.
Yeah. So now you have started to use some other technologies associated with Postgres, in particular Kubernetes and Prometheus.
Yeah.
Tell us what that looks like.
Yeah. So Prometheus is an interesting one in that after we developed the Postgres container suite or container, it became really apparent that there was an opening there to collect Postgres metrics. People wanted to see metrics collection. They wanted to be able to store them, archive them, and do graphs. And that's where I began looking for open source products that would do that. And Prometheus, the architecture of it really caught my attention, and the ease at which I could containerize Prometheus. And then also tools like Grafana, which I use, which plug right in and allow me to graph. So that became an easy on-ramp basically for me to build a Postgres monitoring capability. And being able to leverage tools like Prometheus was really key to me being able to rapidly build out that suite. It's basically a monitoring suite, which is part of the overall Crunchy container suite. Now, in terms of Kubernetes, my initial target was OpenShift, but OpenShift was based on Kubernetes. So this is kind of a easy leveraging of open source. So the container suite, even though my initial customer engagement, people were interested in running it on OpenShift, because OpenShift was based on something open like Kubernetes, it made it really easy for me to now support running the container suite both on OpenShift in its various flavors, as well as on Kubernetes natively. So there's other open source PaaSes now that I'm targeting as well, including Mesos. In the long term, you'll see the Crunchy Postgres Container Suite being able to run on a variety of different deployments, all of those being open source, including pure standalone Docker, open source versions of OpenShift, and also Kubernetes natively and Mesos in the future here.
So now with this capability that you have with Postgres, what are some of the use cases you're starting to see?
Yes, people that are investing in large-scale cloud deployments, this is a container suite that they can just plug into their infrastructure. So it becomes just another toolkit and a way to standardize database deployment within their cloud infrastructure. So that's one case we see. And then there's people that have a need basically to quickly provision up databases on demand, essentially, kind of in a database as a service model. And quickly provision those, use them, divide up projects and data into a large array of Postgres databases. Once those projects end, then they can quickly deprovision those. So that's another use case that we see emerging.
So it makes these databases almost very, I don't want to use the word disposable, but it seems that way almost.
Really purpose-driven,
right?
Task-driven. You could imagine different scenarios around the world when people need to do some kind of data analysis really rapidly. Technology like this enables you to come in, spin up database infrastructure very rapidly, and then take it down as you need to.
Why did you just focus on Postgres?
Well, Crunchy is a Postgres company. That is our niche. We focus directly on the Postgres database, and we have several Postgres committers on the Crunchy team. So we're just totally into Postgres. That is our niche, and that's what we focus on: secure support and service for people that are looking at using the Postgres database. Open source in particular, we use the open source distribution of Postgres, and that's really our foundation.
So tell us then, if you could then summarize the actual technology architecture that you're using I'm curious too on the programming languages that you're leveraging.
Yeah, we start with the open source Postgres bits essentially, and I build those in this container suite just as Docker containers. Inside the container is usually a little bit of orchestrating code or features that I might add on to enable me to add hooks into that container to do different kinds of things outside of the container. But essentially, custom code is all written in Golang, but a lot of it is just bash scripts, so it's very easy for people just to take the container or Docker files of the containers and customize them and tweak them as they want. Some of the more advanced things like metrics collection is custom Golang code that is running in a container. There's about 8 or 9 different containers as well, so each feature is really broken out into its own container. That was a design goal from the beginning, was to really go microservice oriented here, with the concern of each container really is narrowed as much as I can. In terms of orchestration, I obviously depend on things like DNS that Kubernetes or Mesos might have for service discovery. I use things like the Kubernetes persistent volume mechanism for actually creating persistent volumes for the databases. So all of the data is separated out from the CPU with it. So no data is stored within the container. It's all external to the container through different kinds of volume mounts.
Well, Jeff, thank you very much for taking some time to talk with us, and we look forward to keeping in touch about what you guys continue to do at Crunchy Data.
Very good. Thank you for the opportunity to speak.
Thank you. You're listening to the New Stack podcast from Cloud Native Day, brought to you by Cisco. Check out Mantle, Cisco's open source microservices infrastructure, pulling together the best of open source projects, including Docker, Kubernetes, and Ansible. Learn more at mantle.io. That's MANTL.io.